Hi everyone, my name is Hemant Kumar. Today I'm going to present about my project. This is my project MediBuddy. Now I'm going to talk about my project task. First, we talk about that project MediBuddy. This MediBuddy is a digital platform, healthcare platform for an inpatient hospitalization and outpatient services and corporate wellness benefits. This project mainly focus on the patients and their data and all, like their age, gender, and BMI. Basically, these things we'll talk about these things about these concepts only. This my project is mainly focused about that patient's data and how much they're having that data set and all that body mass index, age, and gender and all. Now, this is the basic description about my first task assignment of my data. Now, actually, these are the main tasks for my assignment. First one, we should have to find the gender of the person for a company constraint for exceeding policies or not. Then average amount of money of that company spent on each policy. Next, their advice. These are the main 8 tasks of my project to complete. Now, the thing is, this MediBuddy entire project is mainly focused about the data set. The dataset is a key role to play to find any of the solution of these tasks. Now, if look into the dataset, these are the two datasets I have. This is a one dataset and this is one dataset. This is a first dataset. This dataset mainly focus on the age and gender and body mass index and charges and INR. This mainly focus on these three domains: age, sex, and BMI. These are the policy numbers according to that patient numbers. This is a second data set. It is corresponding to, that means related to this data set only. The thing is policy number will be same and might be same, and this will cover the that patient has any children and is a smoker or not, and is from which region, like southwest or northwest, like a region it will mention. Based on these two data sets, we are gonna get the solution for my tasks. We look into that tasks once again. These are the 8 tasks. This all tasks is related to the data set only. This will cover that gender and body mass index and that address. Everything is there in that data set. Using that data set, I'm gonna get the solution for these 8 questions. Now I'll use Google Colab for getting that solutions. This is my index page. This is my project title, MediBuddy Insurance Analysis, and my name is Manbal Hemant Kumar. This is a basic project summary of my project. That MediBuddy is a digital healthcare platform. Already we discussed about that, and it is in Bangalore currently. And this focus mainly focus on these data sets. One containing that pre-health checkups like age, BMI, as earlier we'll look into that, and another one personal details like number of children he has and smoking condition and location where he's currently staying and all. Next, this is a problem statement. That problem statements mainly consist of that insurance companies faces challenges like policies based on their age and BMI and factors like smoking and number of dependents and location and all. And also they will look to about that children and their healthcare expenditures also. That policies and risk assignment is mainly focused on this MediBuddy. Now we look into that code, how to get the solutions for that. Before implementing the code, we need to upload our documents here. Now we click into these files. Uh, let's wait for some time to connect here. After getting this page, we just have to click that upload. Then we upload that data sets here. I renamed the data sets with 1 and 2 as of my convenient. So then I open here, it will shows okay. Then here we upload the data sets, first data set and second data set. Here we can rename here as your convenience. I renamed that files with the first data set and second data set. Then I'm going to implement my code. This is my first code. Here I'm importing my libraries and all. I'm gonna run this code. After yeah, it's done. Here we will get the tick mark, means it will execute done. Okay, let me close this one. Okay, then we go to the next code. This code mainly refers to the data sets. Yeah, already I told you, right? I renamed my files with one.csv and two.csv. Then execution is done. Then I'm merging that both the data sets and using that policy number. And then executed done. Then I'm just cross checking the data. What the data is same in the both data sets. These are the five data sets which is common in the both files. Then this code is used for data pre-processing. Here I'm using a label encoder. If this label encoder column mainly focus on the sex and region where he is staying and all, and the smoking status of that condition is a yes or no. And then let me execute this. Then after that, just columns that were replacing that policy number, right? In both data sets, we are mainly focusing about that policy number. So we check that column, we drop that columns into that policy number. In place, if it is executes means it will display true. Its execution is done. Then we'll create an okay, let me execute this. Yeah, this one is related to figure of that data set. Like here, mainly we're focusing about x-axis. We are taking 6, and y-axis we are taking as charges in INR. That data sheet shows the box plot like this. This is a box plot using the data we created. See here the passing palette without assigning a hue and deprecating will be removed. Means in and also x where will assign to hue and set legend is equals to false. For that SNS blocks plus x is equals to 6 and y is equal to charges in INR. The data is DF and the palette is set to. This is a graph we are getting based on the data which we have. After getting this graph, I'm going to execute second libraries. These are the few more libraries I'm using. Seaborn and Matplot and Pandas. I'm using these libraries for one more graph. Okay, let me execute this. After executing this, here I'm getting one more graph. This graph consists about x-axis consists about gender and y-axis consists of count. This legend is a title category. This title of this graph is distribution of insurance charges by gender. Based on that gender, it's charging the like female and a male. That count we are calculating using this graph based on the data whatever we have. Okay, next we go and execute next one. And this one will show us about the impact of smoking on insurance charges. No. Currently, I'm executing each and every status, and after that, I will look into the tasks. Currently, I'm doing this impacts of smoking on insurance charges. Then we got the this one like how many non-smokers are there and how many smokers are there. According to that, smoking and what are the data we have. Based on that, we created this graph. Then we go to the calculate the averages of the insurance charges. After calculating that averages, this is a code. Average charges is equals to df of charges in INR dot mean. Here mean means it will calculate the total number of averages of the data sets. What are the persons we have, and this is our total charges. Currently, we are paying that average insurance charges is 13,270.42. Then we are using the train test model and to get the data sets. That means that training data set and testing data set. Normally in machine learning, there are the two data sets. One is training model and second one is testing model. Mostly every data is like 70% will be training model and 30% will be in testing model, or either 80 to 20 also, like 80% in training and 20% in testing. After executing this code, we will get the training set of this graph is x train is 1070, 7 and y train is 1070, and testing data set x test is 268, 7 and y test is 268. Then after that, we are finding that sample predictions. These are the five predictions we are getting using the data that train test and that means training test and testing data. And after that, we are checking that mean absolute error and mean squared error, R to square. using NumPy. Then after calculating that values, here we get that values. Mean absolute error is 871.33 and mean squared error is 4928373.50 and root mean square error is 2219.99 and R square error is R square score is 0.9683. After getting analysis, here's the basic description I added about that analysis of results and that low RMSE. RMSE means root mean squared error, and here MAE is mean absolute error, and highest high R square score is 0.9703. And this model explained 97.03 of percentage of variance, which is excellent. And after that, we look into the tasks. This is the first task that the gender of the person matters of the company as a constraint for extending policies. This is a graph for that one, like sex and charges in INR. This is a code we are using in x-axis. We are taking sex, and y-axis we are taking is charges in INR. Based on that, we created this graph. This is the title of this graph: impact of gender of insurance charges. Next, using that question, we find the statistic value and a p-value, and this is the code for that. Here, t statistic value is 2.0975 and p-value is 0.0361. And finally, we will predict that the interpretation one is either it will be significant difference between two genders or maybe no statistically significant between two genders. Here we will get a statistically significant difference between genders. Then since the p-value is less than 0.05 means we reject the null hypothesis, meaning means that gender does not have a statistical significance impact on insurance charges. Next, we go with the second question. Second question is what is the average amount of money the company spend over each policy? That means the amount of money that it's spending on each policy of the each person, what are the policies they are taken. Based on that, it will spend money. This is the average insurance charges of the company that paying for the each cover. That means each policy. And after getting that average, uh, this is the amount. So average amount of money per policy by the company is 13,270.42. This is the average amount that company were spending on policies. Next, we look into the third question. This is a third question. Could you advise if the company needs to offer separate policies based upon the geographical location of the person? Yeah, we can find that location means that regions we have regions. We can take it at 0, 1, 2, 3. In second region, we have 364 members, and third is 225, 325, and first is also 325, and for zero region is 324. That name count is we use data type int 64. Then we can print that data things. What are the things we have that data types? Age is we're taking int is a data type, and sex int and float we have point values. That's why we take float, and charges also we take it float, and then children smoker and region is int category. Then it's good. The next code we drop that data set subset, and then region, what are the regions we have, then script the stats. That means that regions in every region. In f statistic we that means based on that regions we find the f statistic and p value. F statistic value is 2 point something, and p value is 0.03 and so on. And this is a thing that means that p value is less than 0.05 means we can conclude it is a statistically significant difference between insurance charges across the different regions. Then we go to the next question: does the number of dependents make a difference in the amount claimed? Here we can use ANOVA test for getting that answer. That number of dependents make a difference in the amount claimed. Yeah, of course, it will be a difference based on that policy and the person has disease and all. After getting that results, here we get the F statistic value is 3.2969 and p value is 0.0058, which is less than 0.05. We can directly tell it is a statistically significant difference in insurance charges based on the number of dependents. Of course, it will be there. And next, we can use this one also, Kruskals values test. This based on this Kruskals values test, we find the H statistic value and P value. Here we got H statistic value is 29.4870 and P value is 1.9608 and exponential power um, minus zero point 0.05, that is less than 0.05 only, that p value. Then final conclusion of this is the result confirm that dependents impact the insurance charges significantly. After getting the board, that means after executing the board test, we directly indicate that impact is that company should consider the customized policies based on the number of dependents. That operations is offering that family insurance plans with varying premium structures and adjusting that coverage limits based on their dependents and introducing the discounts or any ads on for individuals with more dependents. Then we look into the next question. Does the study of persons BMI get the company any idea for the insurance claim that it would extend? Yeah, right. Here we are talking about the BMI and the charges we are spending and all. Here we get the BMI is 1.000 and charges in INR for BMI is 0.198341. That correlation is 0.198. That means that correlation value is 0.198 suggests a mild positive relationship, meaning that BMI increases, the increase insurance charges tend to be increased. That means the correlation value positive means BMI increases means then automatically charges will be increases. Then again we creating a plot for that. Here for BMI and the insurance charges. Here we're using the BMI. Here we're using the scatter plot for that impact of the BMI on insurance charges. In this one, in x-axis we are using BMI and y-axis we are using insurance charges in INR. Then it will covers the result for this is the regression plot. This is a regression plot. The regression plot confirms this with a slightly upward trend. See, if you observe this, the graph, it will be a slightly upward. There is a significant stutter over implying the other factors influence charges and more. Then go to the next question. Is it needed for the company to understand whether the person covered is a smoker or not, non-smoker? Yeah, there is a chance it will be a smoker impact. Here it will find a smoker means here we are using 0 for non-smoker and 1 for smoker. And here it is a impact of that smoker one. Then using that smoker, we creating one more graph. This is a impact graph on the smoker. This is a smokers one. This is a non-smoker one, and this is a smoker one. That based on the insurance charges. See here, we are using 0 for non-smokers and 1 for smokers. Based on that, we are creating this. This is for non-smokers and 1 is for smokers. Then we go to the next question. Does age have any barriers on the insurance claim? Yeah, it will be there will be an impact on that one also. Here we are calculating that age and charges in IMR. That means that insurance claimed amount. Here we got 0.29299. There is a correlation one between age and insurance charges. There is a weak positive correlation. That's why, however, this will be a not be a strong correlation means it suggests age alone is not a major determinant of insurance claims. Other factors like smoking and BMI and pre-existing conditions might play a bigger role when compared to this age. And we go to the last question. Can company extend certain discounts after checking the health and status of health status means BMI in the case? Of course, it will check. The correlation coefficient is here. We got 0.198341, suggests a weak positive correlation between BMI and insurance charges. Then BMI alone is not get a strong predictor for insurance costs. Through higher BMI might slightly increase the charges. And this is the graph for the regression plot. Here we're BMI versus insurance charges. This is a regression graph. graph we are getting using that data. In x-axis we are taking BMI, and y-axis we are taking insurance charges in INR. And then this is a basic explanation about that BMI, that scatter plots shows individual data points, and red line helps to understand the overall trend. This is a overall trend. Then if points are widely spread from the line, it confirms a weak correlation. That means these things are weak correlation. Then the correlation is weak means the BMI should not be solo criterion for determining discounts. That means combination of factors like age, smoking habits, and pre-existing conditions should be considered. Then last question, in addition to the above analysis, build a machine learning model to predict the amount of spent at the utmost accuracy, and validate the hyperparametrically tune another model to get the results. This is a code we are using here, random forest, for that. Using a random forest, we are getting the best accurate prediction. After using that random forest, here we are fitting 5 folds for each 20 students. The total is 100 fits is there, and the first MA is 844.4945, and outline this means root mean square error, and that is 2126.7718, and outmay the R square score is 0.97086, and these are the best parameters of that one. That means the NPI estimator is 100, and minimum sample split is 2, and minimum sample sleeve is 2, and maximum depth is 10. And these are the values we are getting for that. And conclusion, this analysis is used to help the optimize insurance pricing and risk assessments for MediBuddy. Here, key findings are smoking and a high BMI and geographic location significantly impact on claims, while gender and number of dependents have minimal effect. These are business effect like risk-based pricing for smokers and high BMI individuals, and location-based premiums for to reflect regional healthcare and costs, and wellness incentives and discounts for healthier lifestyles, and optimized family and senior plans for better coverage. And that's all about the first task of my assignment of my project. And my name is Hemant Kumar. This is my mail ID, and this is my phone number. This is all about my first task, which was part of my project and internship. And thank you for giving this task. That's about my task. Thank you.